Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss elasticity, idea of stress, strain, coefficient of elasticity and elastic constants. Let's begin. What is elasticity? This is the property by virtue of which it recovers its original size and shape when the external or deforming forces are removed is called elasticity of the body. Deforming force, we say, what is that of deforming force? If a body suffers change in size or shape under the action of external force, it is said to be deformed. That's why a force under which the body changes its shape and size. In this way, elasticity is the property of that body. That means it recovers its original shape and size when the external force are removed from that body. This is the property, that is elasticity. Some terms related to elasticity, that is strain. Strain is defined as the ratio of change in configuration to the original configuration. We compare the configuration of that body before or after by introducing an external force. The calculation of that deformation, or we can say the change in configuration to that of original configuration, is the strain. It is of three types. One is longitudinal strain, volume strain and shear strain. What is longitudinal strain, or we can say it as linear strain? It is the ratio of change in length to original length. Since it is longitudinal strain, that is the change in configuration to original configuration. We compare the configuration in between the original to that of change in configuration. That's why longitudinal strain is the change in length to that of original length. Volume strain, the ratio of change in volume to that of original volume. Shear strain, shear means change in that of angle. What is that of angle? It is the angle through which a line which is originally perpendicular to a fixed surface gets turned. That is known as the shear strain. Strain is of three types: longitudinal strain, change in length by original length; volume strain, change in volume by original volume; and shearing strain, that is the change in angle by that original angle. That angle is the through which a line originally perpendicular to a fixed surface gets turned, that is the angle. This is known as the shear strain, or we can say it is the shearing strain. Again, what is stress? We define what is stress. When external deforming force acts on a body, then internal forces come into existence within the body to resist the deforming force. It is due to the internal resistance force the body regains its original size and shape. So, the restoring force per unit area of that of body is called stress. The restoring force per unit area is called the stress. But in that of equilibrium state of the body, the internal restoring force is equal to that of opposite to external force. So, the stress can be measured by the external force per unit area. Of their applications in so many fields. Dimensionally, we can say its dimensional formula, that is the stress, that is force per area, m1 L minus 1 T minus 2. the dimensional formula of stress, and its unit is Newton per meter square in SI inches, that is dyne per centimeter square in CGS. This is all about stress, restoring force per unit area. What is that of restoring force, or we can equilibrate to that of restoring force to the deforming force. In this way we introduce stress. Again, Hooke's law. The law states that within elastic limit, stress is directly proportional to strain. That is why the ratio of stress by strain, is a constant, and that constant is known as, that value of the constant is known as modulus of elasticity, or we can say it as coefficient of elasticity. That is the modulus of elasticity, or we can say the coefficient of elasticity. The ratio of stress to strain is a constant, and the value of that of constant is known as the modulus of elasticity and the coefficient of elasticity. On this basis, we define so many elastic constants. We have to discuss one by one. See here, what are the elastic constants? First one, that is Young's modulus. Young's modulus, written as capital letter of Y, that is Young's modulus. How we define Young's modulus? One of the elastic coefficient. It is defined as the ratio of normal stress to the longitudinal normal stress, or we can say it as the longitudinal stress to that of longitudinal strain. Stress by strain is the coefficient of elasticity. Since it is one of the coefficient of elasticity, this is the ratio of stress by strain. Which type of stress? That is the longitudinal stress, or we can say it as the longitudinal strain. Mathematically we have to formulate. So if F is the force along the length of the wire, let we consider a wire and a force F is applied along the length of the wire, and the length be, let it be small l, and the area of cross section be let A. This is, let's capital L is the length of that of straight wire. Let change in length, let it be del L. Del L, let it be the change in length when a force of F acted, or we can apply a force along the length of the wire. Originally its length will be L. After that applying the force, that length change. The change in length, let it be del L. According to the definition of Young's modulus, Y is equal to longitudinal stress by strain. Longitudinal stress to longitudinal strain. Longitudinal in the sense that is lengthwise, or Young's modulus longitudinal stress, that is force F applied, area A, force per area, that is the stress, divided by longitudinal strain, that is change in length by original length, change in length del L divided by original length. Mathematically we can say that is F L divided by A del L, that is force length divided by area into length. That's why its unit will be how much? That is Newton per meter square, square of the meter in SI, and dyne per centimeter square in CGS. Young's modulus, that is longitudinal stress by longitudinal strain. Another elastic coefficient, bulk modulus, or we can say it as the volume elasticity, denoted by K. When a uniform pressure is applied all over the surface of the body, when a uniform pressure is applied whole over the surface of a body, then the volume of the body changes. Since we applied a pressure, that is uniform pressure is applied whole over the body, then the volume of that of body changes. The pressure applied is the normal stress. Pressure is nothing, that is the normal stress. That's why the bulk modulus is the ratio of normal stress to the volume strain. Normal stress, stress to strain, that is normal stress to volume strain, is known as the bulk modulus. Mathematically we can say, if V is the original volume, let we consider V the original volume, dV the change in volume, change in volume due to we applied a uniform force, that's why change in volume occurred. Then mathematically the bulk modulus K is equal to minus P, P that of stress, stress is in the form of pressure, and volume strain, that is the normal stress, P to that of volume strain, strain that is change in volume by original volume. Strain means change, let you take longitudinal strain. Longitudinal means length, change in length divided by original length. We take it as volume strain. Volume strain in the sense that is change in volume to that of original volume, that is change in volume dV divided by original volume V. Here the negative sign, we introduce the negative sign, means that indicates with the increase of pressure, with the increase of pressure, definitely the volume decreases. That's why we implement a negative sign to that of mathematical expression. This is the mathematical expression to that of bulk modulus, that is normal stress to the volume strain, and its unit will be how much? That is Newton per meter square, or we can say dyne per centimeter square in SI, in CGS. Again, the reciprocal of bulk modulus, that means 1 by K, that is the reciprocal of bulk modulus, we can say it as the compressibility. What is the compressibility? Compressibility is nothing, that is the reciprocal of bulk modulus. Again, another elastic constant, that is modulus of rigidity, and it is denoted as Neeta. It is the ratio of tangential stress to shear strain. Stress by strain is any elastic constant. Here, for that of modulus of rigidity, it is the tangential stress to that of shearing strain. So, we can mathematically formulate that elastic constant. We take an example. If F is a tangential force applied to upper face of the cube, let me take here A, B, C, D. Let A, B, C, D be the upper face of that of cube, or any face of that of cube where the lower face of that of cube is fixed. If F is the tangential force applied to the upper face, then the face experiences a shear and assumes the shape A dash B dash CD. When we applied a tangential force to the upper face of that of cube, whereas the lower face of the cube is fixed, that's why this tangential force F creates a shear. Shear in the sense change in angle to that of original angle. Then the shear, let we take the shear, let it be theta. The shear strain, let we can say the shear strain, let theta, which is an angle through which the vertical side AD and BC have been turned. When the vertical side AB and BC are turned to an angle theta, this also turned to an angle theta. Let capital L be its length and change length A to A dash, let it be small l. Therefore, the tangential stress is equal to, that is F applied force to that of area F by A. Shear strain theta, shear strain is the theta, theta is equal to, that is small l divided by capital L, small l divided by capital L, that is the shear strain. Where we can consider, where A dash is equal to B dash is equal to small l, and AD is equal to BC is equal to capital L. That's why shear strain theta is equal to small l divided by capital L. Now, our aim is to find out modulus of rigidity. Therefore, modulus of rigidity, that is Neeta, is equal to F by A divided by theta, that is tangential stress to that of shear strain, or is equal to Neeta is equal to F by A divided by L by L. Now we can easily find out its unit. Its unit will be how much? That is Newton per meter square or dyne per centimeter square in CGS. This one is in MKS or in SI. This is the modulus of rigidity, that is tangential stress to shear strain. Last one, that is Poisson's ratio. What is Poisson's ratio? We denoted it the symbol sigma. Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain. Lateral strain to longitudinal strain. When a body elongates in the direction of tensile force, it experiences lateral contraction. That is, the contraction in the direction perpendicular to the direction of tensile force. So, it is accompanied by both longitudinal strain and lateral strain. We can mathematically solve it. Look here how we define all these things. Let it be capital D, let it be capital L. Since it is strain by strain, that is why it has unitless since it is unitless, or we can say it is also dimensionless. It has also dimensionless, and it is a constant. Overall we can say it is a constant, since it is strain by strain, that is lateral strain to that of longitudinal strain. Let consider a wire of length L and diameter D subjected to force F causing change in length del L for that of elongation. In that of elongation, the length changes to that of del L. This is the length L, and when we force applied, the length changed. The change in length, let it be del L. And contraction in diameter, for contraction in that of thickness by del D. This is the diameter of that of length. When elongation takes place, or we apply that of force, by applying the force in longitudinal direction, the change in length del L, and again there will be a contraction in that of diameter, and the change in diameter let will be d minus del d. So longitudinal strain, that is change in length to that of original length, change in length del L. This is the original length, this is the final length, so the change in length is del L. Del L be the change in length to that of original length. Again, lateral strain, that is lateral, that is the diameter, change in diameter to that of original diameter, change in diameter will be d, del d, original diameter capital D, change in diameter. So the Poisson's ratio will be how much? That is a longitudinal strain to that of lateral strain. Longitudinal strain is del L by L, lateral strain del D by D, or we can say sigma is equal to del L by L divided by del D by D. It has unitless and it has also dimensionless quantity since it is a constant. So with the help of this video lecture we understand what is elasticity, strain, three types of strain: longitudinal strain or linear strain, volume strain, shear strain, stress. What is stress and its dimension, unit, Hooke's law. With the help of Hooke's law we introduce the modulus of elasticity, or we can say it as the coefficient of elasticity. There are so many elastic constants by using this concept of Hooke's law. One is Young's modulus, that is longitudinal stress by longitudinal strain. Any ratio of stress by strain is one kind of elastic constant. Bulk modulus or volume elasticity, that is normal stress to volume strain ratio of. Then modulus of rigidity, Neeta, that is ratio of tangential stress to shearing strain, its unit and dimension. Final one, that is Poisson's ratio, it is the lateral strain to that of longitudinal strain. So with this useful and informative notes, let me wind up this session. Thank you.